Hello, here I will show about CVAT development. This is our document report. Here I done some explanation about CVAT, and you can read it about the CVAT components and Redis queue and deployment nodes, adding alloyed hosts and ports and other things. And my work starts from here, the new feature. Here you can see. Okay, I use this Git branching style for development. I've done several branches which start with Mohammed underline, and the main branch is Mohammed underline develop, which you can use for deployment. One important thing is setting up a development environment. Development environment works outside of Docker, and it's very easier to debug and develop if you want to add and modify features. So yes, first we should follow this link here, and yes, we need to use it in Linux, Ubuntu, for example. Here we need to install these requirements. These for Linux environment. Next, you need to install Visual Studio Code. For development, it's a text editor and IDE like PyCharm, IntelliJ, Atom, and so on. And in a directory, you need to clone this repository, which is actual my repository, and you go to CVAT and make some dirs. Here I cloned CVAT. So yes, I already have these folders. So I go on. With this command, you create a new environment, a Python environment, which is a virtual environment. Then after that, you need to activate that. So you should see something like that here. You need to install real and pip like this, and then install Python requirements for CVAT. Here are database migrations, which creates tables and relations, and here create some collect statics, and I think it's for logs maybe. Next, you need to add a super user to be able to log in. And after that, you run Visual Studio in the virtual environment like this. So here I have Visual Studio. Inside Visual Studio, install debugger for Chrome and Python extensions. Here, for package, you search for Chrome extension here. And install this. Okay. Next, you need to reload Visual Studio Code. And for debugging, you can run like this. I will show you. Let us go back. Yeah, here you go to debug, and you see here some options. If you select server debug, all of the components for CVAT will run, but I will do it manually. Here you see a Django server actually, which is our web app. We have two Redis database actually, which the default default used for importing photos and creating a new project. And this one is more important for us because we use it for annotations, and TensorFlow will run inside this. And also you can run Chrome here. So for the first time, you will see a login and password thing. You enter the username and password that you recently created to see this page. Here you can create a new task, and here you should add all of the labels that you want to be annotated, like car, truck, person, and so on. But before that, and yes, here you can stop everything, and below here you can still log for any part, for example Django process and RQ processes and Chrome. There is a folder here, .env. Let's check from the document. Yeah, how to run CVAT components, for example, new auto segmentation development environment. We need also clone mask our CNN. So inside CVAT. So here we're inside CVAT, and here you could clone. So after cloning, you see mask or CNN here. Next, you need to download mask or CNN coco.h file and put it inside mask or CNN. Yes, here we have it. You can do it with this command. It will download this file inside mask or CNN folder. Next, you need to copy these two lines to CVAT.env being active. So I copy these two lines. And here you will see activate. At the end of the file here, you can add these two parameters. These two parameters are checked by Django, and it makes it appear in the UI. So I also here added TensorFlow annotation and the path to inference graph, but here is something that we want. And after doing that, you need to run this command: deactivate, activate. So it reloads the environment, and again you run VS Code. So we close this code, and here we run VS Code again. So here we could run our project. So with this will automatically here different components of CVAT that makes it fully functional. So here you could see it's available. One important thing is here RQ default shows process for creating new projects, uploading files, but here RQ low is used for TensorFlow process, and you could see, for example, the log here that it passes this function called this the labels and the ID of the task. Here you could see the logs for Google Chrome, and that's it. So where to edit here to replace your model? You can skip this area because it's not relevant, but you can still read it. Here, yes, in auto segmentation, this is a part about my work on auto segmentation. You can see the algorithm used and how to import exports from the representation. I told here some things and dependencies. They're not important, but because they are installed automatically. I told about the parameter of approximation. I don't think you need to change it. It's on a good value. And here are instruction to deploy to production, not this development area. And after that, you see two parts. Where are the new files and where are the modified files? Here is all of the files I added to CVAT project. All the files inside here, CVAT components, auto segmentation, all the files here, CVAT apps, auto segmentation, and I explained all the files here. This file is being used by Docker when you use Docker commands. You add this Docker compose file and this shell script run, which clones Mascar CNN and Cocoa H5 header, which we already done in development environment, but it automatically done in Docker, inside Docker. And here's the more important part. There are the files. You can see the change that I done easily on GitHub. There are all the things I've done, the new lines, and also some edited parts. You can see these parts have edited. So you can, for adding a new feature, you could just follow everything that I done here. All the changes are visible here. But where's the main codes are here in views.py inside apps auto segmentation. Okay, so the main part is this view.py, which I described functions inside it. I could show it in the code. You could see outlines inside this project, in this file actually. Yeah. First of all, this function will be called using REST API HTTP, or when you click on run auto segmentation. Here it creates a new Redis queue. The labels will fetch from the database. Here are the labels defined for our model, not from CVAT. It will map the labels to each other, these labels and labels from CVAT from the database. And here this process runs. It runs with a different process. So after calling this, it immediately follows to this line, and it won't wait for output for this create thread function. So the next function that is called is create thread. Here I also done some comments. There is a threshold for accuracy of detection. It then initialize RQW again. You get the task model, the data about task. It makes also image list, which is function inside here. You don't need to change it. And the result here will run with this. And it will wait for the result to be returned. And after that, you will see the result will be converted to CVAT format and serialized to be stored in a field in database. So this function will store our annotations to database. And the next time we refresh the project, we will refresh the CVAT, we will see the annotations. So what happens inside run TensorFlow to segmentation? This is the main algorithm and codes here that needed to annotate. That's actually the TensorFlow process. I also done here image commentings, and I also explained here. You can read about it. Yeah, I set a root directory which is defined. It's the same thing that we defined here, right? Or in Docker it will be set automatically. These are the common lines from ask RCNN. Note that here I didn't use batch processing and only actually one process at a time, one image at a time on one GPU. It will load the model and the weights, and it's the main loop, the object detection, and it's the result that will be returned. Here it's the index or frame name. Image name is the frame number, or the index of the image actually, and this is the path for that image. First, it checks if the job is cancelled. So it checks inside Redis, and if it was cancelled, it will return and will delete this job inside Redis. Here we do the progress. We make here the progress with image num and save it. Next we load the image, then the detection process with one image, and because it supports batch processing, we need to use the first element because we give only one image here. So and this is the loop for creating the format. So so we do this for each detected class IDs, and if the detected class is not in our CVAT project, it's not defined in our CVAT project, it will be removed. Next, it will be removed detections under the threshold. These two lines not important. It was for creating and returning boxes, but we don't want boxes. We want polygons. And yes. So mask or CNN returns us a mask, not a polygon, not points. It's a binary mask. So because it's a binary, because it's Boolean, we need to convert it to int. It's simply convert the matrix of values to integer, to 0 and 1s instead of true and false. Then we will convert it to segmentation actually, which is finding contour. Let's check. These two functions are defined here in our function. Actually, it's simply return and change it to uint8, and here I will find contours using scikit. I give the mask. Here I have the contour, because it was only one. And next, well, the important part is here that we need to approximate the polygon, because it will create a lot of points to store. So editing it is impossible. So we need to decrease the number of the points, use approximation with this parameter, which works good. Next, it makes it to a list actually, and return the segmentation. So here we have some segmentations, and the label, using the labels mapping, the label for CVAT actually will be added to result. Yes, append will add result with this label. For example, the results for cars, there are a list of image number and the segmentation. Image number, again, I will say it's the frame number. It's the index of the frame, index of the image. So you say which image and where is the segmentation and what's the label, and it will be returned. So you need to change here. You can do anything here. You can do PyTorch or anything. Here you could see I included new things like from SkyMage and yeah, NumPy and so on. And you could see just import PyTorch and things like that. So I explain it here. So for deploying to production and Docker, you need to for deploying to production, you could use this command. This is, I will explain it. This Docker Compose file, it's the main Docker Compose file, and the following Docker Compose files are override to this Docker file. They change some values inside it and make, for example, auto segmentation available. And it's a Docker Compose override, which is used for changing the allowed has, we could check. Yeah, deployment node. It's better to create a Docker Compose override and add these lines, for example, allowed hosts, and the port you want to be used from outside. This is the outside, and it's the port inside CVAT container. So for using this, I need to connect to a remote host. Okay, here I cloned CVAT, and here you need to copy these lines. So if you want other components to be added, you can just add another if, for example, components CUDA, for example, and Docker Compose CUDA, and so on. But no, I just want to use it here. Yeah, if everything goes well, you will see these 3 lines. It's important to see all of them are done. The CVAT Redis, CVAT DB, which is Postgres SQL, and the CVAT, which is the Django and the TensorFlow process, and so on. So let us check yes, here actually you need to create a new user actually, and here you will see a login page which I done. So let's test it in the production. CDS data test. Here we, for example, add car, person, truck. I don't know. You need to add labels that are supported with Cocoa database. And here I use some examples. I need another files. Because I'm inside Windows, I could